Good afternoon, everybody. I hope you are doing well. Today we will try to solve this question. Uh, Ways to split array into three subarrays. This is a LeetCode medium question. I have never solved this question before, and I will try to solve it today. So we are given an array, and we want to split it in three sections. So we just go back here. So we are given an array. So let's say this is an array. And basically, we want to try to break this into three sections, A, B, and C. We want to split it in three sections such that sum of this A is less than equal to sum of B. And I believe it has said, yeah, and sum of B should be less than equal to sum of C. So three sections, I should say. We make them capital A, B, C. Okay, so this is how we want to split them. And I have to count the number of ways such that this can be done. Of course, uh, they cannot be overlapping, and I believe there should be at least one element in each section. Yeah, non-empty contiguous arrays. So if I say that this is the starting of, say this is the array. Okay. So if I say that this is the start of second, and this is probably the end of second. So start and end of second can vary. And if it satisfies condition, then we can accept. So if we use these two pointers, start and the end, so we can say that this can be my section A, this can be my section B, and this can be my section C. Of course, as the start of second and the end of seconds roam around, the B section shrinks and expands accordingly. Okay, so if we are playing with these two pointers, so start can move from here to here anywhere. End of second can start from next of the start and then go up to here. So it's kind of an n square complexity. So n square time complexity. And that will not be acceptable in this case because n is up to 10 to the power 5. Of course, these sums can be computed in constant time by using simple prefix sum technique. Okay, so we have to be smart. We have to not use these two pointers while maintaining this based on some value of C. So if this is C, I have to know what are the possible starts of and ends of B. Not necessarily brute forcing, but maybe finding it in a smart way. Let's see that with an example. Let's say we are given 1, 2, 2, 2, 5, 0. So this is given to us. Now let's say this is the end, or let's say this is the start of C. So this is the fixed C. And for this C, I know the sum is 5. So I must split this section into two sections such that if I select the first section, that should have sum less than equal to 5. And whatever section I choose here, the rest section should have sum less than equal to whatever section I have chosen here. Okay. That means here, if I start, I can only go up to the element such that the sum is less than 5. So this I can choose, this I can choose, but this I cannot choose as the start of second array, because if I select this as the start of B, then this sum is 6 and that kind of violates my condition. So I have to select this in such a way such that the sum is less than this. So imagine we have a suffix sum setup. So if this has some suffix sum, this has some suffix sum, this has some suffix sum, this will be sorted. This will be sorted in nature. So I can find a point, peak, such that that is the maximum I can have. Maximum I can go from this. I believe all the elements are positive, right? So that, yeah, yeah, all the elements are positive. So, so this will kind of form a mountain-like structure. Prefix sum, of course. So I can use a binary search in order to find the point in which I am just less than. Of course, all the like this can be a valid end, valid start of second. This can be a valid start of second. This cannot be a valid start of second. So if this becomes the valid start of second, then the sum is I can calculate through prefix sum. If this is the start of second, I can calculate it anyway. Calculate it. So, for example, let's say this array is known. This is the start of C. And for this start of C, I know this sum. So using binary search on this peak, I have found out that this is the minimum start of or maximum start of B. So that means in this range, I can choose any B, but hold your horses. If if I start B here or in this area, it is possible that this sum can exceed this little sum. So there will be a maximum start of B, and there will be a, I should say, max, yeah, minimum start of B, or yeah, max start of B, and there will be a maximum end of B. How is the maximum end of B be defined? Such that if I take, if I select this to be the maximum end, that means if I select one more in B, then that, based on this start, is going to cause problems. So this is how I am kind of thinking about approaching this problem. So let me just define some constructs. So we are given this array 1, 2, 2, 2, 5, 6. If this is the end, this is the max, what says the start of. So this can be a start of B because this sum is still less. Now I have to find, I think I can find it based on this sum. So this sum is 3. So maybe I, if I select this to be the start, uh, Yeah, so what I will do, first I will brute force on start of C from the end. Okay. And based on this sum, I will find out the start of B or minimum place, or sorry, maximum index from A can start. Like if this becomes the start of B, then this sum is 6, so no. So that I will find by binary search. And after finding this, I will know this sum as well. So that sum is 3. So that this can be the start of B. Question is, can this be the start of B? No, because if this becomes the start of B, then the sum of B is 2. But sum of A is, I believe, 6, 5. And that cannot be possible. So we have found one solution such that for this 0, 5, only 2, 2 is the split. For 0, I will not get any split, because if this is 0, then I cannot even cross this little section, right? That will only increase. There is no B possible. For 0, 5, 2, the sum is 7. So 2, 2, 1, I can take up to 7 sum. So this I can take, this I can take, this I can take. But of course I cannot, all the subarrays have to be, cannot be non-empty. So I cannot take this, but I can take this one. So this is the start of B, or I should say max. Yeah, so maximum index, max start. I cannot go further than this. I cannot take 1 because it has to be non-empty, because the sum of this is 7. So now this is possible. So 4 sum, which is less than 1. So this is the start of B I have found. Okay. Now what I will do, I will get this sum, suffix, prefix sum, of course. And then I can see, then I will try to see that based on this start of C less than C, what is the maximum I can go? That will be this. So this start and this end are the two possibilities. So let's say this is the index I1 and this is the index I2. So I2 minus I1 plus 1 is my number of possible splits for this configuration of C. So this, in this case, we found 2 configuration. This case, we have found 1 configuration. 0, 5, 2, 2. If I do this, then 2, 1. Only 1 configuration possible. So total 1, 2, 3, 4. I believe 4 should be the answer. Or it's saying 3. So 1. Wait, we have done, I think 1, 2, 2, 2, 5, 0. Yes, this is a configuration. For here, we have found 2 configurations. Wait a minute. So 50, yes, we have 1 configuration. 250, we have 250, we have only 1 configuration. Let's see. Okay, it's saying that this is correct. This is correct. But for this two, we have only 1 configuration. Let's see. Oh, no, 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 no. You see, this sum is 1. Na? If this sum is 1, I have to greater than that. So if I take this entire thing as B, so 1, 4, 7. Good split. If I take this as B, 1, 2, and then 2. Based on this sum, no, I cannot be, it cannot be based on this sum. That means I have to, the first thing I have found. The second will be such that, let's say this is the array. The C is already defined. I have to find a split such that this sum is less than this, less than equal to this sum. So 1, I believe that this will be 3 and this will be 5. So I can take a split here. So 3 plus 1, 4. This is 6, I guess. And the sum here is 2. So 6 minus 1, 3. It should be 5. So the sum here is 4. But the sum up to here is 5. So 5 minus 4 is 1. Mm, okay, 5 minus 3 I should do. Yeah, so this is 4 and this is 2, which is not acceptable. But if I take 1, 3, 5, this I take a split, then this sum is 1, and this sum is, I guess, uh, 5 minus 1. So 5 minus 1 is 4. So which is acceptable? So a second binary search. So what I was doing, let's see. So the idea is that, let me clarify my approach. So let's say these are some elements, okay? So let's say I find a split and I know the sum is x, let's say, with the split. So I know that this is what it looks like, right? This is an increasing array. Let me just copy this. So imagine this like, this is the split, okay? And let's say the sum is x. Sum equal to x. Now I know that this array will look like this. So I can find the minimum point such that sum is less than equal to x. Because if this sum is x, I cannot have sum here greater than equal to x, can I? So let's say I find this point, minimum point. So let's say this is the minimum. Let's say this is the minimum point, okay? Now, it's not like I can take this minimum point, this, all I will be able to take, not necessary. Because uh, if I take this, so this part is satisfied according to this. But what if this sum gets greater than this sum? Then it's an issue. So this is the minimum point I have found. I have to also find the maximum point. So this is the prefix sum. This is suffix sum, by the way. This is the prefix sum. And let's say this is A, this is B, this is C, this is D, this is E, this is F. It's prefix. Now, if I, when can I do a split? Like I have to know that this A plus B should be less than equal to this. Then I can do a split here. Can I do a split here? If A plus B plus C should be less than equal to D plus E plus F. That also I can do it through binary search. That the rights, because it's monotonic in nature, no? Like there will be only one breaking point. That after this sum will become less than equal to greater than this sum. Right? So these two binary searches we run for every brute force value of X. This is what I am thinking. Okay. So let's try to implement this. And basically the 2 points I find, L r minus L plus 1 is the number of answers I get for this particular X, of this particular value of end point or start of the third array. Okay. So let's try to implement this. So it's not charging. What? Okay, it is charging now. So let's think. So I need both prefix and suffix sum. So let's be define. I will just call, let's name Z, and I can just name R A minus 2 to 0. Basically, I run from n minus 2 up to 0, and I say that suffix, let's say s, suffix of I plus equal to suffix of I plus. Let me just use the template so that all the definitions are defined. Okay, why is it verifying again? Okay, until then. So also I need a prefix. Uh, let me give it some time to open up. So I also need prefix now. This will be U and ER maybe. And for this, I need a F that will run from 1 to n minus 1. First, let's define this n. So basically the size of my vector. And I can just say prefix of I that's equal to prefix of I minus 1. Okay, I believe the VS Code has opened. Yeah. I was doing some other questions. From I think this question is this is from some old Codeforces conferences. Okay. Okay. So the prefix and suffixes are defined. So now I will run a loop from this is C, the start of C. And that can be from n minus 2 up to, I believe, 3. right? Cannot be. So now I need to know the sum from the SC index to n minus 1. So that can easily be calculated using prefix sum. So int capital C, I can say, or I should say this is LL C equal to prefix n minus 1 plus, okay, so I should say prefix of n minus 1 plus, or minus, I should say prefix of, I believe, SC minus 1, because the start of C I have defined as SC to the end. Okay, so this is the sum of the last vector. Now I need to find the minimum start B. So LL minimum, so MSB, let's say, MSTB. So minimum start of B. So suffix is kind of the mountain, like the reverse mountain. I need to find a point from 1 to SC minus 1 such that the sum from that point to SC minus 1 is less than equal to my capital C. And I want the minimum point. Okay. So maybe some binary search on answer is helpful. Let's see if this is running. It's saying that why is it running so? You know what is wrong with this? Okay, so just lagging a little bit. What is this shell? Yes, LeetCode. So this is just a basic for LeetCode I use for fine. And we learn on answer research. I'm gonna define these. Gonna all of these setups. Why is it not logging in? The binary find, binary search. Yes. I don't know why I'm should be available. Anyways, so this after this being defined, so let me just put this binary search here. So this is what it says that. So I will try to define this low as 1. The high should be SC minus 1. And the result, the initial result. So in my case, I want the lowest point such that C is defined. So result can, in the worst case, the result can be SC itself. Then maybe nothing is found. And mid is of course. So we try. And if it is possible, so we try to go lower. Otherwise, we go higher. We don't have to print this race. We just have to say that int mstb equal to s. Okay. And now we define this possibility function or the predicate function. Now we want, okay, how do I define that this mid is valid? If this mid is valid when the sum from mid to SC minus 1 is less than capital C or less than equal to capital C. So I will say the sum from mid to SC minus 1 is less than my capital C. Now, of course, this sum from mid to SC minus 1 is not defined. So we can make a function maybe auto sum equal to maybe some, it will take in L int R. And I will return that if L equal to 0, return pre R, otherwise return of L. Of course, I want the return type of this to be LL. Otherwise, I'm kind of in trouble, right? So P of L minus, sorry, P of R minus P of L minus. That should work. So whenever, so return, I would say the sum from mid to SC minus 1 is less than C. This kind of works well for me. These I don't need, this LLs, these being LL is sufficient in my case. So this gives me the minimum. I also need the maximum MSTB. So maybe I should define pos2. Now, of course, I cannot have these redefined again. Okay. Of course, for the end, the low can be maximum. Wait, in this case, the low can be 1. No, the low, yeah, low can be 1 because 0, 1. In this case, also the low can be 1. The high can be up to SC minus 1 or SC minus 2. Like if it is SC minus 1, no, it's SC minus 2 because like if this is SC and the B is SC minus 1, the starting, then that one element can be a possibility. Here, I'm saying that it's like that was the start of B, that will be the end of B, right? The end of B can be SC minus 1. And result, do I need to define? Let's think. And again, we want to maximize this, right? So if it's a possibility, then maximize. Otherwise, minimize. And let's think, like, how should I define this high? So for first array, so 1, I mean 0 starting. It can end at 0 as well. We are playing on the index of B, right? Like, that was the minimum index of B. Now I want the maximum index of B. I believe the recording is running well. So yeah, what is this binary search? No. Anyways, so let's keep it up to SC minus 1. Yeah, if that is SC minus 1, that is also SC minus 1, then only one B is possible. Okay. So, and result equal to, let's say, also SC minus 1. And this is also result. Of course, I need to find a way that it is impossible. Result equal to 0, I should say. So yeah, like I did not find any split. In this case, of course, this pos 2 I need. In this case, I want the sum from my 0 to mid, right? So I want the sum from 0 to, I believe, mid minus 1, right? To be less than yeah, I should say mid to SC minus 1. I guess. Because if I define my mid, is this one visible? Yeah, so this is not working. Maybe I need to refresh this. So think of it like I'm playing on the index of B, right? So 0 to, so this is the, let me just disconnect and reconnect. Will this work, I guess? I refresh this. Yeah, it's working now. So what can I do here? You see, like in this case, 1222250. So for this, starting at 5, I can only go up to here. And for this, and now I need a split here as well, right? If I pick this as mid, the sum is 1. Of course, I cannot have this mid here because that's the starting. Yeah, of course, let's have the mid here. I can say that if the MSTB is greater than MSTC, then we can ignore 0. If I pick the mid here, then this is 1 and this is 6. Good. Can I pick mid here? So this is 3 and this is 4. So good. Can I pick the mid here? So this is 5 and this is 2. So not good. So this is the last point. I got good. So only one possibility. So 1, 2, and then 2, 2, 5, 0 is the only possibility for this split. And I think that is also given in the, for 5, 0, only the 2, 2 can be the split. Okay. So this is what we have done. That the sum of this 0 to mid minus 1 is less than MSTA, so sorry, MSTB and MASTB I have found. So if I say that if that MASTB is less than MSTB, then continue. You are not getting any answer. Otherwise, let's say define a result. Not result, I should say answer equal to 0. So answer equal to answer plus this MSTB minus MASTB plus mod. So mod and this entire thing mod. Okay. So maybe in the end we'll done. We've done correct section. Let's define this mod. Plus mod. I really don't know why this is not working. Let me try to run this. Okay, I have defined 2 sums. To remove this one sum because it's default accumulate function. Okay. Expected 1 here also. They are always returning 0 for some reason. So can I just PR MSTA, MSTP, MSTA? No output. Mm, Let's think. So we print here. Here I have went. So SC from n minus 2 greater than equal to 3. N is 3, right? Okay, it should not be 3, it should be 2, right? Let me print this C. No output. Okay, what is so n is 3. Good. So 3 minus 2 is 1. Okay, okay. Mm, Yeah. So 3 here. So capital print C will work. So 1. Yes, we are getting 1. Then the sum becomes 2, and in the end the sum becomes, does not matter. Okay, for 1, MSTB is 2. I'm just putting ln here. So 1, and then we have a 2 and a 0. So 1, SC is 2. Let's see what is going on. So 111, right? So will this be visible? So 111. So for this, so SC equal to 2. This is the range. So kind of this. So I should set this is 1 and this is 2. Suffix. So I will choose this such that what is the sum of C? I believe it is 1. Yeah, and SC value is 2. So now this is good. So MSTB should be 1, right? Why is MSTB coming out to be 2? Mid equal to 1. Let me define this raise as SC minus 1. Okay, less than equal to. Okay, 1, 1, good. So R minus L plus 1. There can be some edge cases, I guess. So 2, 3, 5, 10. Let's see. Expected is 3. So let's choose for 10. Then I got 1 to 15. So 15 is the sum. Okay, okay. So for 10, I got 1, 2. This is 1. This is 2. Yes, so 0, 1, 2, 3. Answer equal to answer plus. So yeah, 2 minus 1 plus 1. So this contributes 2. Yeah, it's correct only. Why did I output 1? MSTB. MST. What is the value of SC? I guess SC value is here 0, 1, 2, 3. Where did I define answer? Outside only, na? This is correct. So 2 minus 1 plus 1. What's this? Okay, it will be ASTB minus MSTB. Yeah, silly mistake. So that minus this plus 1. Okay, it got accepted. I believe you understood this solution. Just some silly mistake. Basically, we found out the lower bound, find out the upper bound. It's not very fast. I don't know why. It's a binary search solution on answer, of course. That will be all for this video. Thank you very much for watching. I believe you understood. So this is exactly the same approach. This result equal to SC means I did not find any solution. Like it can be any big number like int max in order to, specify that I don't have an answer. Similarly for this result, I set it to 0 because I'm starting from 1 now. If I don't find any answer and it is 0, then this will fire. And that will lead to not being considered, that will lead to this answer not being considered. Okay. Thank you very much for watching. Have a great day.